Alright, so I want to have a look at this concept of graphing a straight line, which you've probably seen a little bit before, and I want to talk about it as a linear function. If you look at that word linear, you can see line in there. The idea of a function is some sort of relationship between two variables, and often in maths we use the variables x and y. So we might have something like y equals 2x minus 1. And so it's a relationship. As x changes, y changes. There's a little bit more to the actual formal definition of a function. I won't go into that right here and now, but you might like to look up and see what that is. Right now we're just going to look at the linear function. I know this is linear because the power of x is just x to the power of 1. If it was an x squared, it would no longer be linear. I'd start to get a curved graph rather than a line graph. So anyway, y equals 2x minus 1. So one way to do this is to plot some values for x and y, and to plot those points and join up as a straight line. One thing students often ask me is why do I pick particular values for x? You can pick whatever values you like for x. So I normally go values like that, around 0, somewhere around 0 and either side of 0 I'd normally pick for these. Now you could change those values and pick different values. You've got to start somehow though by picking some values for x, and then what we're going to do is substitute each of these in here to work out the corresponding y value. So 2 times negative 2, negative 4, take away 1, negative 5. Keep going, negative 1 times 2, negative 2, take away another 1, negative 3. 2 times 0, 5. So now I know for every x value I have a y value, and I could use this, if I just look at that, as an ordered pair, negative 2, comma, negative 5. And so on a nice, neat axis, I can plot this point, negative 2, negative 5, by going across negative 2 and down to negative 5, and there it is. Negative 1, negative 3, again you can consider that as a ordered pair of coordinates, negative 1, negative 3. 0, negative 1, across 0, down 1. 1, 1, across 1, up 1. 2, 3, across 2, up 3. 3, 5, across 3, up 5. And you can see that these points are starting to form a straight line. And it makes sense that I should, in fact, draw a straight line through these because there's lots of points I've missed that the straight line will cover, such as this value here when x is a half and y is 0. So the straight line covers all the other points in between that I've missed. Putting arrows on it says the line will continue beyond this, beyond the points that I chose to put in my table, and it will continue in the same fashion. And hence it's a linear function. Here's the relationship. As x is increasing, y is increasing, and it's doing it in a straight line fashion. So that's one way to graph a straight line, one way to graph a linear function. It's probably not the most efficient way. It's probably actually the slowest way to do it. A much more efficient way is to have a look at any 2 points and just graph those. Because once I have 2 points, all the other points just stay on the same line. So realistically, I only need any 2 points to be able to graph a straight line. And the best 2 points are what I would call my x and y intercepts. So here's my y-intercept down here, and here's my x-intercept. Now I can see that the y-intercept occurred when x was 0. So I've got my y-intercept at x equals 0. My x-intercept would have occurred when y was 0. So if I come back over here, I'm thinking about how do I graph with x and y intercepts. I know that for the x-intercept, y is equal to 0, and for the y-intercept, x is equal to 0. So if I have a function, a relationship given to me in this form in particular, x plus 2y equals 4, then what I can do is I can find my intercepts. For the x-intercept, I'll sub in y equals 0. So I'll get x plus 0 equals 4. And so for the x-intercept, sub y equals 0, you get x plus 2 lots of 0 equals 4. And therefore x equals 4. It's simply losing the y. X equals 4. So my x-intercept is 4. So I could then graph that over here and go, there's my x-intercept, it's at 4. For the y-intercept, I want to sub x equals 0. And so in that case, 2y is going to equal 4. Quickly solve that little equation, dividing both sides by 2. I get y equals 2. Now those 2 points are enough for me to say that's the line that joins them. So with those 2 points, the x and y intercept, I can draw a straight line which will represent that function and cover all the points in between, and also putting arrows cover all the points that go beyond that line as well. Once we're graphing straight lines, we want to keep looking for more efficient ways, and we want to look at relationships, what's happening in these straight lines. So I'm going to start by looking at some transformations. Start with a very simple graph, y equals x. Now I know that for the x-intercept I'm going to make y equals 0. That means that x is 0. For the y-intercept I'll make x equals 0, which means y is 0. So that doesn't really help me, I've only got 1 point. So I could do a little table of values here, but you could also think of this a bit more intuitively rather than just trying to follow a method. You could say y is equal to x. So in other words, when x is 1, y must be 1. When x is 2, y must be 2. That's 3 points, that's more than enough for me. This will be this straight line up here at a 45-degree angle. And that'll be the line y equals x. Now what I want to have a look at is what about a line like y equals x plus 2? I just want you to stop for a minute and just think and make a prediction what that line would look like. Okay, let's have a quick look at this. So we'll do this with our intercepts. We'll say that the y-intercept occurs when x is 0. So that means the y-intercept here is 2. So a y-intercept of 2. And the x-intercept occurs when y equals 0. So I get x plus 2 equals 0. Solve that equation by subtracting 2 from both sides. X is negative 2. So I'm getting this as my x-intercept over here. Now have a look at this graph. I'll graph this one here now. And it's passing through 2. So you can see that the y equals x plus 2 transformation was simply to take my y equals x and move it 2 units up the y-axis. So what we want to do is keep looking for these sorts of patterns in our lines. So if I said to you now on this, I want you to draw this up, I want you to have a go at graphing y equals x minus 3. So here's the solution to y equals x minus 3. The y-intercept, x is 0, will give me y equals negative 3. So passing through negative 3 down here. The x-intercept, y is 0. I'll get 0 equals x minus 3. Adding 3 to both sides. X equals 3 is my x-intercept. So do that. X equals 3, be there. And then I'll graph that. And hopefully that matches what you'd already done. In that you had the original graph y equals x and you just moved it down 3. What I want you to do now is I want you to go explore some other transformations. Try things like y equals x and then try y equals negative x and see what happens there. And then after you've done that, try y equals 2x as well as y equals x and compare those transformations. So have a bit of an explore of those.